Okay, so in this video we're going to look at how to try to determine which rule to use between the sine and cosine rules, between angle and side rules, etc. Because sometimes it's a bit confusing when you just see a triangle with a bunch of stuff written all over it and trying to figure out what to do. So this worksheet's designed to help us figure out which rule to use and how to apply it. So a few things that I want to go through are just these examples. So for the cosine rule, in this case you're looking for a side, so we'd say the cosine rule for a side. We know it's going to be a squared is equal to b squared plus c squared minus 2bc cosine a, but as a shortcut rule for you that you might remember if you are not so strong with your algebra, is that we want to take a square root of all that stuff for your final answer. So it would be square root, bracket, all of that stuff, bracket, to get your a. And when we look at problems like this, the way that we know that we want to use it is that given that we're looking for a side a, we know that we need to have a side that's unknown. In this case, as an example, we see a is unknown. And looking at the other information, we know we need two sides given to us and the angle. And in this case, it's very specific that we need two sides with the angle sandwiched in between. Okay, so in this case, one way to think about it is side, angle, side. If you go around, we go from side to an angle to a side. We kind of get all that information in there. Side, angle, side. And in this case, also you can think about it as the angle is sandwiched. Sandwiched in middle of the two angles, or the two sides that we know. Okay, so again, two sides are needed and one angle, and it has to be in the middle. So we need to be given a side, angle, side type of situation, like you see here, 7, 60, 9. So 7 centimeters, 60 degrees, and 9 centimeters all sandwiched in between each other. And that allows us to then have, if you want to add to this, this becomes our B, 60 is our big angle A, and 9 is our C, our additional side. And from there you can plug it straight into your formula. Looking at the next example, the cosine rule for angles. And as our shortcut to remember this one, to actually get the final answer, it's going to be cos inverse of all of that stuff. And remember, you need brackets here to make it work. So bracket b squared plus c squared minus a squared, bracket, divided by 2bc, in brackets with one bracket to close it all up. Alright. So here, because we are looking for a big A, we are looking for the angle, and you see that here. And we need all three sides. This is kind of an obvious one compared to the rest. It's the only one where you just need all three sides. And it doesn't matter where the angle is that you're looking for, because all three sides will be important. From here, the last bit of information that you need to do would be to label the sides, and we could see across from angle A, we'd call that A. We could call that B, and that C. And A, B, and C would go straight into your formula and give you your answer. Looking at the sine rule, in this case for sides, to remind ourselves, the shortcut formula here would be A is equal to B over sin B times sin A. And the situation here can be a little bit varied, but we can see here that the side that we're looking for is not sandwiched between the angles. So the side that we're looking for is kind of outside of the two angles. So if you go around in order looking at these things, you'd get an angle, and then the side that you're looking for. So one way to think about it with letters would be that you need an angle and a side, or a side and an angle. Or you could also have, yeah, I guess that's the way to look at it. But in this case, you see that the side that we're looking for is not sandwiched between angles. And in this case, we're also given two angles, so that's just another key thing here. So two angles is another hint, compared to this one up here, which was two sides. So two angles here. And we'd go ahead and label the diagram. We can see that this would be across from A, side A, so that's going to be angle A. We'd call this B and call that angle B. and then you'd plug into your formula. Looking at the last example here, the sine rule, and this here being for sides, remembering that our shortcut for this one is actually going to be a is equal to sin inverse of sin b divided by b times a, all in brackets. And here we need the two sides and an angle. And here the angle has to be sandwiched again. I'm sorry, the angle is not sandwiched in this case. The angle is actually on the side. So I need to come up with a different diagram. Nope, I've got this diagram. Sort of okay. We will do this. Sorry, change that to this side here. And we'll call it 40. So what we get here is we need two sides, and we also need an angle, and the angle here has to be outside of the sides to make it happen. So this is kind of like an SSA, if you will. And if we were going to come in and label this, we see that we have an A and across the way little a. So I'd call that B and call this one B. So it's kind of helpful to just label some of the information, and it can help you decide if you've got enough information for the formula. One thing that you'll notice for the cosine rule is that you need A, B, and C information. So for the cosine rule, you're going to use A, B, and C, more or less, to try to find the information. Down here, it's really only going to be A's and B's, and no C in this case. And that's another way to think about doing that. So I guess we just have to try it out and see how we go. So let's look at these example problems that are below and make sure that we can do them. So we will pick the rule. We'll look at number 1, thinking about our sheet. And what do we know? So sometimes it's helpful to start by labeling. Here's the unknown A, so I know that across from it's going to be a big A. And I see here if I go clockwise I can get a B and a C. So like I just said, I'm hinting at that idea that I've got B and C and I'm looking for an A, so it's probably a cosine rule because I've got that information. I also notice that I've got a side, an angle, and a side, so the angle is sandwiched in between those sides. And that tells me, just like we had at the top here, that this is going to be the cosine rule for sides because I see that it's sandwiched in between that information. And looking also at what I know, just from my formula, A will be equal to the square root of bracket, I know B, I know C, I know B, and C again, and I actually know the cosine of angle A. So there we go. All that information is given to me, I know that from my formula, and I plug that in carefully with my brackets, I will get 14.2 centimeters. Looking at question 2 over here. Let's take a look at what we know and what we can label. So there's angle A. Obviously I'm looking for it. Across the way would be side A, and then I'd have B and C. And here I notice actually I've got all three sides, and I'm looking for an angle. So this reminds me here I'm actually looking for the cosine rule as well, in this case for the angle. So the cosine rule, if we rearrange it for the angle and plug straight in, would be cosine inverse of a bunch of stuff. So we've got cosine inverse of B, so 15 squared, plus C squared, which is 8 squared, minus 10 squared, in brackets all over the top. And then underneath we'll have bracket 2 times 15 times 8, and one big closing bracket. And if we plug that in carefully as well, we'll get about 38 degrees. So for both of these, it was the cosine rule. And again, one thing to notice here is that I did actually pick up that there was side C in both of these problems, which is needed in both of those formulas. So if you have a side C, you can be thinking side C is going to be a cosine rule of some sort. I guess that kind of gives us hints about what these next two problems will be, but let's see how they work out. So again, start with what you know. Label what you know. So I've got a side A that I don't know, so across from it is going to be angle A. Then going around, I can label that side B and call this angle B. I notice that there's no side C involved in there anywhere, so it's not going to be the cosine rule. It is going to be the sine rule. And here I'm looking for the sides, so I'll use the sine rule for sides. So A is going to be equal to B, which is 9 over sin of B, so sin 30, times sin of A, which is 80. And when you plug that into your calculator, you get 17.7 centimeters. Looking at the next problem, I guess this is number 4, number 3. Labeling what we know, so here's my angle A that I'm looking for. All the way across the way, I notice that I've got a 5 centimeters, so I'm going to call that one A. And the next side, you'll notice going clockwise like I usually do, there's nothing there, so I'll just go on to the next one and call it B. And then the angle across from it is going to be angle B. And our shortcut rule for this is going to be A is equal to sin inverse sin B, which is 40, divided by B, which is 8, times A, which is 5, is going to be equal to 23.7 degrees. So here, I'm not using side C at all, it's only A's and B's, and in that case it's just going to be the sin rule. And in contrast again, if you're using side C somewhere in there, you know you're going to be using the cosine rule. So to summarize that again here, put it in words. If use side C, those are going to be the cosine rules. So C for cosine. Okay, give a go at some of those practice problems and see if you guys can get the hang of it.